You know, some galaxies out there just look perfect. They're smooth, serene, they look like they haven't changed in billions of years. But what if I told you that quiet exterior was hiding a secret history of cosmic violence, a missing atmosphere, and a chemical fingerprint that just doesn't add up? Okay, let's dive into the fantastic case of Messier 89. It's a cosmic detective story millions of years in the making. So meet Messier 89. Now, in visible light, it's about as simple as a galaxy can get. It's what's called an E0 elliptical, which is basically just astronomer speak for being almost a perfect sphere. It just looks like this calm, featureless ball of old stars, a quiet little citizen of the cosmos. But, as we're about to find out, when you look at it through a different kind of eye, that peaceful image is completely, totally shattered. And wow, this slide just says it all. On the left, there's that calm, ordinary-looking galaxy we were just talking about. But on the right, when we look with an X-ray telescope like Chandra, we get a completely different picture. We see this ghostly, superheated plume of gas just being ripped away. Suddenly, what looked like a serene little sphere is revealed to be a galaxy right in the middle of an incredibly violent event. And it's not just the gas either. When astronomers took these incredibly deep images, they found these faint, telltale shells of stars wrapped around the galaxy. And you know what that means? Those are the leftovers of smaller galaxies that M89 literally devoured in its past. So yeah, this perfect galaxy is actually a galactic cannibal with a super turbulent history. Now, to really get what's going on here, you need to know the setting. Messier 89 is about 52 million light-years away from us. That's a huge distance, and it's not out there all by itself. It lives in this bustling, crowded neighborhood called the Virgo cluster, which is this massive collection of galaxies all swirling around a common center of gravity. And trust me, this crowded neighborhood is the absolute key to this whole mystery. All right, so that brings us to clue number 1 in our investigation, that massive X-ray ghost tail. Where in the world did this enormous plume of gas come from, and what could possibly be powerful enough to create it? Let's look a little closer at this X-ray image because the details really tell a story. You can see the main remnant tail of gas stretching out, get this, for about 10 kiloparsecs. That's over 30,000 light-years long. You've also got this sharp upstream edge, which looks exactly like the galaxy is pushing headfirst into something. And then there are these bizarre horns peeling off the sides. Everything here is screaming that M89 is moving at an incredible speed through some kind of dense, invisible stuff. So what's this powerful force? Well, it has a really cool name, ram pressure stripping. See, the space between galaxies in a cluster isn't empty. It's actually filled with a very thin but incredibly hot gas. So as M89 plows through this stuff at over 1,000 kilometers a second, that gas acts like a powerful cosmic headwind, and it's literally stripping away the galaxy's own atmosphere. So, the tail is explained by ram pressure stripping. Case closed, right? No, not even close. Because when scientists looked at the chemistry of the gas that was still left inside M89, they found something that completely broke all the rules. And this, my friends, is where the real mystery begins. Okay, this is the crucial part, so let's break it down. Think of it like a chemical recipe. Astronomers expected M89's atmosphere to have a solar recipe. That just means its mix of elements would look a lot like our sun's, which is the standard recipe for the gas between galaxies. But what they actually found was a super solar recipe, one that was way richer in heavy elements. In fact, it was a chemical signature that perfectly matched M89's own stars, not the gas floating around it. It was completely wrong. And this was the baffling question. The ram pressure should have stripped away all of M89's original atmosphere. But the gas that's left behind, it's not the original stuff, and it's not from the surrounding cluster either. It's something totally new, with a completely different pedigree. So, how is that even possible? Well, to solve this puzzle, researchers came up with this really elegant two-part theory. And it's an incredible story, not just about losing an atmosphere, but about building a brand new one from the inside out. Okay, let's rewind the clock. This first panel shows M89 in its youth, way before it ever plunged into the chaos of the Virgo cluster. Back then, it had a totally normal, extended atmosphere made of that standard solar gas. Material was flowing in, material was flowing out, everything was pretty much in balance. Then, it entered the cluster, and a two-pronged attack began. Just look at this middle image. That cosmic headwind, the ram pressure, starts stripping the atmosphere away from the outside. But at the exact same time, the supermassive black hole at M89th core fires up. It becomes an active galactic nucleus, or AGN, and it unleashes these powerful jets that act like a cosmic leaf blower, blasting out the rest of the original gas from the inside. The galaxy was basically scoured completely clean. And here is the brilliant part of the solution. With all the old, solar-type gas gone, and with new gas from the outside being blocked by that cosmic headwind, a new source took over. As this last image shows, the galaxy's own aging stars are constantly shedding material through stellar winds, and this material, born right inside the stars themselves, is naturally rich in those heavy elements. This supersolar gas slowly started to build up, creating a brand new atmosphere, literally from scratch. Now, you might be asking, how sure are we about this theory? Well, very. On the left, you have the real Chandra X-ray image of M89. And on the right, that's a computer simulation of this exact stripping and refueling scenario. The match is absolutely remarkable. The simulation perfectly reproduces the sharp edge, the long tail, even those wispy horns. It gives us a huge boost of confidence that this is what's really happening out there. But if there was any doubt left in anyone's mind, one final piece of evidence just sealed the deal. And it came from comparing M89 to another galaxy that provided the perfect control for this cosmic experiment. Just look at this comparison. On the right, we have NGC 1404. It's another elliptical galaxy, and it's also being ram pressure stripped, just like M89. It's got the tail, check. But there are two huge differences. First, it does not have an active black hole, and second, its atmosphere has a perfectly normal solar chemistry. The active black hole, the AGN, is the smoking gun. It tells us that the black hole was the critical accomplice that blasted out the old gas, making room for the new, star-forged atmosphere to take its place. And hey, don't just take my word for it. As the researchers themselves put it, the black hole's outflow facilitated the stripping. In other words, it wasn't just the cosmic wind. It was this perfect conspiracy between the forces outside the galaxy and the engine deep inside it that led to this complete atmospheric transplant. So we've solved the mystery. But why does one galaxy story 52 million light-years away actually matter? Well, it turns out this cosmic crime scene opens up a whole new window into how our entire universe works. You see, Messier 89 isn't just some weirdo galaxy. It's a perfect natural laboratory. It shows us in incredible detail that supermassive black holes don't just sit in the middle of galaxies. They can fundamentally reshape their homes. It shows us how cosmic weather in galaxy clusters drives evolution. And maybe most profoundly, it proves that galaxies aren't these static, unchanging objects. They are constantly, and sometimes violently, evolving, so much so that they can even replace their entire atmosphere. Which really just leaves us with one final, fascinating question. Messier 89 looked perfectly normal until we knew how and where to look. It really makes you wonder, how many of those other quiet, serene-looking points of light in the night sky are also hiding their own incredible stories of total destruction and rebirth?